points in the polar coordinates. If suppose the 3 points, one point P r1 comma theta 1, second point Q r2 comma theta 2, third point r3 comma theta 3. Required area of the triangle formed by these 3 points in the polar coordinates. Now first take O as pole, OX as polar axis. First point P r1 comma theta 1. Now P r1 comma theta 1. Then the distance between O and P is r1 and OP inclined an angle theta 1 with polar axis. Next point Q, r2 comma theta 2. Then OQ equals to r2 and OQ inclined an angle theta 2 with the polar axis. Third point r3 comma theta 3. r3 comma theta 3. Then the distance between O and r3 and it inclined an angle theta 3 with polar axis. Now required area of the triangle OPQR. Area of the triangle PQR required. Now area of the triangle PQR, area of the triangle PQR equals to area of the triangle OPQ, area of the triangle OPQ plus area of the triangle OQR minus area of the triangle OPR, area of the triangle OPR. Now area of the triangle OPQ equals to half into OP into OQ into sine of angle between OP and OQ. But sine of angle between OP and OQ equals to theta 1 minus theta 2. Now sine of theta 1 minus theta 2 plus area of the triangle OQR equals to half into OQ into OR into sine of angle between OQ and OR, that equals to sine of theta 2 minus theta 3 minus area of the triangle OPR. Now area of the triangle OPR equals to half into OP into OR into sine of angle between OP and OR, that equals to sine of theta 1 minus theta 3. Now that equals to half into OP equals to R1, OQ equals to R2. Now sine of theta 1 minus theta 2 plus half into OQ equals to R2, OR equals to R3, sine of theta 2 minus theta 3. Now in sine of theta 1 minus theta 3 equals to minus sine of theta 3 minus theta 1. Now minus of minus place half into OP equals to R1, OR equals to R3, sine of theta 3 minus theta 1. Now that equals to half into sigma of R1 R2 sine theta 1 minus theta 2. But area always positive, then modulus square units. Now it is area of the triangle formed by 3 points in the polar coordinates. Example, find area of the triangle formed by the points 0, 0, 5, pi by 2 and 7, pi by 3. Now area of the triangle formula, half into sigma r1 r2 sin of theta 1 minus theta 2. Now, but in this r1 equals to 0, theta 1 equals to 0, then we get only half into 5 into 7 into sin pi by 2 minus pi by 3, or that equals to 35 by 2 into sin 30 degrees, or that equals to 35 by 2 into 1 by 2, that equals to 30 by 4 square units. Now it is the required area of the triangle with the given 3 points. We find the equation of the straight line. Now if suppose O is the pole, OX is polar axis. Now a straight line passing through pole and inclined an angle alpha with the polar axis, inclined an angle alpha with the polar axis and passing through the point P. P is any point anywhere on the required line. Now P coordinates r comma theta, then OP equals to r, OP inclined an angle theta with polar axis. Then the required equation of the straight line theta equals to alpha. Now it is the required equation of the straight line passing through pole and makes an angle alpha with the polar axis. If suppose O be the pole, OX is polar axis, a straight line, the length of the perpendicular from pole to the straight line is P, and the perpendicular inclined an angle alpha with the polar axis. Required polar equation of the straight line, polar equation of the straight line. Now first let P r comma theta be any point anywhere on the required line. Then OP equals to r units and OP inclined an angle theta with the polar axis. If suppose P and ON perpendicular to required line. Now required equation of the straight line Pn, required equation of the straight line Pn. Now in triangle OPN, angle O equals to theta minus alpha, theta minus alpha, and ON equals to P. In triangle OPN, cos theta minus alpha equals to ON by OP. Cos theta minus alpha equals to, but ON equals to P, OP equals to R. Then required equation of the straight line is R into cos theta minus alpha equals to P. It is the required equation of the straight line in the polar form. Now the length of the perpendicular from pole to required line is P and the perpendicular inclined an angle alpha with polar axis. Next example, find the equation of the straight line.